Friends and colleagues, we welcome to the stage ECE past, current and future presidents and experts in the field of rare diseases, cancer in endocrinology, environmental endocrinology and endocrine-disrupting chemicals, and obesity, to remind you of key discoveries in endocrinology in the past 20 years.
Excellent. That worked out very well. So endocrinologists are good keepy-uppies. That's absolutely good to see. Yeah, that's what we expect from you. So I hope everybody feels now fully activated for our plenary session on major breakthroughs in endocrinology over the past 20 years, which is the first half, and then future breakthroughs that we imagine. And we've put together a panel for this, but we will start with a few things. So these are our conflicts of interest, always good to list. Yeah. And now we will do something interactive again. Yeah. And the first question is, you open your app, I will show you a QR code in 1 second. What were the greatest endocrine breakthroughs in the last 20 years? What do you think they are? Technically, we can only accept one word, but you could obviously make it a long conglomerate word. Okay, what were the greatest endocrine breakthrough in the last 20 years? Get the QR code. Directly, it's good to do this directly. You don't need to go through the app, but you should have the app on your phone. And everybody ready? Yes, they look convinced. So I start the voting. Twenty-seven seconds for you to think through what were the greatest endocrine breakthrough. Your favorite endocrine breakthrough in the last 20 years. Tell us about the biggest breakthrough from your perspective in one word, so that we see the word cloud. You saw already the video we were showing what was selected for our 4 areas today. It's very big breakthroughs, but we are very keen to hear from you. Cool, wow, there's the word cloud. Kisspeptin, welcome to my friends from Imperial College. Hypoparathyroidism, closed loop, copeptin, welcome to Basel. And trans identity, genetics, leptin, artificial steroid inhibitors, GLP-1 analogs, SGLT2. Emmanuel, very good. Research is definitely a breakthrough for all of clinical practice. This is wonderful. Thanks for this. And you see there are a multitude of breakthroughs. And we'll put this into nice form and we'll place this on the website. But this is really super exciting. So obviously we can only select a few of those in our 4 areas. And now I have to close this and close the voting. Cool, and then now I present you the panel, obviously apart from myself and Miriam Christ-Krein, who's the future president of ECE, who will start her term mid-next year. We also have 2 of the ECE past presidents here, Jérôme Bertherat from France and AJ van der Lele from the Netherlands. And then we have in the first round 4 senior experts, which is Elena Valassi from Spain, who will talk to rare endocrine disease. Guillaume Massier from France will talk to cancer and endocrinology. And Paulina Damdimopoulos from Sweden will talk to environmental endocrinology and endocrine-disrupting chemicals. And then last but not least, Lisbeth van Rossum from the Netherlands will talk to obesity breakthroughs. So we start with Elena. So Elena, I start your presentation. Welcome to the lectern.
Thank you, Wiebke, and thank you for the invitation to talk about the breakthrough in rare disease in the last 20 years. So definitely in the last 2 decades, there have been several steps forwards in this field, especially thanks to the development of profiling techniques that have considerably advanced the genomics and produced also an explosion, we could say, of molecular endocrinology, and because these allow to unreveal the molecular mechanisms underlying rare endocrine disorders, and these pave the path to important changes in the diagnostic and therapeutic paradigm. For example, precision genetics applied to diagnosis definitely caused a shift from a symptom-based diagnosis to novel classification precisely based on molecular network and signaling pathways, with important implications, for example, to shorten the diagnosis. We know that delay to diagnosis is one of the most important pitfalls in rare disease, facilitating family screening and risk stratification. There are several examples, but one of the most important is probably the SDH pathway mutation identification in pheochromocytoma and paraganglioma. And then all these, in terms of another important implication, is certainly the implementation of the theranostic approach, extremely important in NETs to improve localization and staging, but also to develop or to offer the patients alternative treatment in case of unresectable metastatic refractory tumors. And very important, the preparation, the development of targeted therapies. Again, another change, another shift from supportive management, so symptom-based management based on the control of symptoms, to disease-specific treatment. And this is particularly important in inherited metabolic disease with the consequent improvement of survival and quality of life. For example, in achondroplasia, the development of vosoritide, which is the C-type peptide natriuretic peptide analog therapy, which produces an improvement of growth and body proportion in these patients, but also in X-linked hypophosphatemia, so the development of burosumab, which is the monoclonal antibody against FGF23. Again, its use was associated with a significant clinical and biochemical improvement. And then another important step forward is represented by the implementation of analytical strategies, in particular metabolomics. We know very well that these allow the identification of metabolomic biomarkers which are associated with severity of the disease, treatment response, prognosis, and again, an important help in terms of shorten the diagnosis and offer a personalized medicine. So we are talking about a personalized endocrinology, actually, and there are several examples of this advancement and the usefulness of this approach. A classical example could be the discrimination between malignant and benign adrenal tumors. Another important advancement is represented by the pharmaceutical technology, which produce many steps forward. Let's think of chronotherapy, for example, and the development of modified release agents for adrenal insufficiency and congenital adrenal hyperplasia, for example. But in general, the preparation and the development of novel formulation with a better tolerance, safety, and efficacy profile. For example, the recombinant PTH replacement or long-acting recombinant growth hormone. And also the transient conjugation technology was also important in pediatric and adult growth hormone deficiency, in hypoparathyroidism, and achondroplasia. And then, last but not least, I think it's very important in the last year, the increase, a significant rise in the awareness of rare disease in terms of both investment from the European institution. For example, we know very well that in 2019 was launched the European Joint Program on Rare Disease, now ERDERA, which is even more ambitious than before, because apart from supporting high-quality patient-led research, also want to promote the development of a European clinical research network. And on the other end, it's clear every day more, actually, that it's important to generate global research networks, international registry, collaborative genomic database, so unite the efforts to face with rare disease and approach them effectively, also through patient and healthcare provider networks, and also the involvement of patients with rare disease in multi-center trials. So also important, the involvement of a pharma company. And certainly, as I mentioned before, also the patient's empowerment has been very important and significant in the last years. So now patients are actively involved in the decision-making process, and also they are important part of a strategic partnership which influence the research priority and regulatory decisions. And ECE is in the front line of this because currently there are 30 affiliated patient advocacy groups to ECE, and also ECE try to involve patients in several manners. For example, we are at the Congress now, so through the Patient's Voice sessions. So thank you very much for your attention.
Many thanks, Elena. And now we have Guillaume talking to breakthroughs in cancer and endocrinology from his perspective.
So I'm very honored and happy to be there to try and bring up some major events that happen in the field of cancer and endocrinology since 20 years. So first, the omic revolution. You take endocrine tumors, you combine it to omic techniques, and what do you get? Incredible progresses in pathophysiology, diagnosis, prognosis, and treatments. And this was applied to pit nets, to thyroid and parathyroid tumors, to adrenal tumors, but also to nets, pancreatic, and nets from other origins. And I know that many of the authors are here in the room. So that was really changing since 20 years. So if we think about cancer 20 years ago, at this time we were mainly considering cancer as the disease related to abnormal tumor cells. Now the picture has evolved, and we see cancer globally as a more complex disease, implying the tumor microenvironment, the host organism, and the environment. And if we apply these 4 levels to endocrine tumors, we can say that these 20 years were really, really incredibly sources of progress. First, we had targeted therapies, totally new, with outstanding effects. Of course, there was the immune checkpoint inhibitors coming out, who could also make some miracles in subsets of endocrine tumors. And related to the host organism, I think that the most striking was the progress of local regional treatments for slow-growing endocrine tumors and slow-growing cancer in general. Now patients live longer and better with all these progresses. And related to environment, I think that disruptors have emerged as significant causes of the subset of endocrine tumors. But as endocrinologists, of course, we also want to see how hormones impact globally these 4 levels of cancer. First, on tumor cells, of course, we knew for prostate and androgen, breast cancer and estrogen, but more and more it becomes generalized that hormones impact tumor cells directly. On the tumor in microenvironment also, hormones have a huge impact. It's obvious for glucocorticoids, but other hormones also have important impact, and this is a field that emerged since 20 years. At the level of the host organism, what came out in the 20 years is the importance of the metabolism and physical activity to prevent cancer, but also to change the outcome of cancer. This is really new. And related to environment, of course, as you all know, endocrine disruptors are now detected and become a matter of public health, and the ECE has been very prominent into bringing the voice of endocrinologists to highest levels of European policy makers related to this topic. So now let's have a tour through our nuclear medicine friends, because they also had revolutions. And I think their major revolutions are related to endocrinology. First, let's consider the radiopharmaceuticals that emerged since 20 years. It really changed the way we see cancer. But look at their tracer. It's glucose. It's from us. Dopamine, somatostatin analog derivatives. All these tracers are from endocrinology. Iodine, you might say it's not new, but the redifferentiation is really groundbreaking and novel. And then there are these new therapeutics combining a radionuclide, such as lutetium or radon, paired to what? To hormones, to small peptides, but also to antibodies. And this has started, especially in NETs, and of course it's just starting and it's going to become more and more important. So the most important aspect, in my view, is also the human networks that emerged from these 20 years related to the topic of endocrinology and cancer. And ECE has been really proactive through the focus area, through the endocompass. We also talked about the implication of patients and of industry. And of course, the ERNs with special topics dedicated to cancer and endocrinology. And of course, networks, research networks in Europe. And several networks were successful into bringing high science, friendship, and really outstanding progress. And the purpose of this picture is not to show that some of us are now not as young as they were, but just to tell to the eyes and all younger colleagues, it's not now your turn to take it over. Thank you.
Fantastic, Guillaume. Yeah, and networking, we have already emphasized this morning in the plenary sessions, as super important. And now we come to our third topic. Paulina Damdimopoulos from Sweden will present her view.
Good afternoon, everyone. My name is Paulina Damdimopoulos, and it is a pleasure to represent the past. So my task is to summarize the breakthroughs in research of environmental endocrine-disrupting chemicals over the past 20 years. Now, compared to endocrinology at large, that started sometime in ancient Egypt or Greece, the field of environmental EDCs is relatively new. I can in fact still speak with people who witnessed the evolution of the entire field. The first signs of endocrine disruption in humans started emerging soon after the first synthetic estrogens were taken into medical use in the 40s. However, it was until the 90s when the concept of environmental chemicals disrupting the endocrine systems was formalized. Then a group of experts got together at Wingspread, and they released a statement. We are certain of the following: a large number of man-made chemicals that have been released into the environment have the potential to disrupt the endocrine systems of animals, including humans. The initial focus of the EDC field was much on estrogenic effects, a lot because of these synthetic estrogens that were the original source of the observations of adversity in humans. And it was long thought that these steroid-like structures was a hallmark of all EDCs. However, the past 20 years have really shown that this is not the case. For example, the forever chemicals, the family of PFAS, they are long alkyl chains with fluorine-carbon bonds, and they do not resemble steroids. Yet they can disrupt the endocrine system. For example, the thyroid hormones and the lipid metabolism, and thereby they contribute to human adverse health, like high cholesterol or disrupted reproductive health. And it was actually reproductive health issues that brought the EDCs to the attention of the public. In the 90s, the first reports of sperm count decline were reported, and the discussion soon followed whether there was an environmental component explaining this phenomenon. And ever since then, male fertility has been in the spotlight of EDC research. However, the past 20 years have taught us that EDCs are much more than sperm. For example, they can disrupt the neurodevelopment, leading to increased risk of neurocognitive disorders and lost IQ points. They can act as obesogens, disrupting the insulin, glucose metabolism and contributing to diabetes and metabolic syndrome. And they can even disrupt the immune system, affecting susceptibility to disease. And all these effects are actually especially linked with early life exposures. And this was also clear from the start. The effects of EDCs are dependent on the timing of the exposure. The women who took diethylstilbestrol while they were pregnant, themselves they had relatively few health effects, but the fetuses exposed in the womb had increased risk of different diseases through their lives. So we've really learned over the past 20 years that the early life exposures, when the organ systems are forming in the fetus, are particularly problematic. And these type of exposures are then linked to later life reproductive, metabolic, and neurocognitive health outcomes. Now there's animal studies that suggest that this type of effects could even be inherited in animals down to generation 5. We humans have only lived with man-made endocrine-disrupting chemicals surrounding us for about 3 generations now. So how far will the consequences of the chemical landscape we have today go down in the future? Time will tell, of course, but I would like to state that the past 20 years have really consolidated that original statement by the expert. We have released and keep releasing large numbers of human-made chemicals to the environment that can disrupt the endocrine system and cause a lot of adverse health outcomes through our lives, of course, in line with the central role of the endocrine system in human overall health. So the real question is, will we do something about this before it's too late? Thank you for your attention.
Many thanks, Paulina, and obviously this spans obviously present to future very importantly. And Lisbeth van Rossum is now taking her place to give her view on the breakthroughs in the past 20 years on obesity. And we will open the floor after her talk, and I will first ask the 2 past presidents on their views, but then you can line up at the microphones there and to give comments or suggestions or questions, and the panel will discuss it. Okay, Lisbeth.
Well, thank you so much, Wiebke. Well, over the past 2 decades, obesity shifted from a lifestyle issue only to really recognized as a chronic endocrine disease with also effective endocrine therapies. And well, one of the foundational breakthroughs was the recognition that obesity is really a neuroendocrine disease, with key discoveries in the mid-90s that includes, for example, the obesity gene with its product leptin, and we heard all about it by Jeffrey Friedman, also this Congress. And leptin is being produced by the fat mass, and it shows also that fat is really an endocrine organ. But also the discovery of the MC4 receptor that showed that body weight and also appetite are hormonally regulated. Then also there is the FTO gene, which is very important, was the first common variant showing that obesity is also partially biological driven, and of course in interaction with a highly obesogenic environment, because we all consume way too much food which is ultra processed. Now this actually paved the way to better understanding to leptin melanocortin pathway, which is basically how our appetite and weight is being regulated. And this gradually paved the way for targeted therapies also in, for example, monogenic obesity, and that's a field in which really endocrinologists play a major role. Now this is this pathway in a little bit more detail, and here you see the major advance that was the development of an MC4 receptor agonist in 2016. And for the first time we could really treat obesity based on its underlying biology, and this marked the beginning of precision medicine in obesity. Now another turning point was in 2007, and that was the time that the Swedish obesity subject study that yielded long-term data from Berg surgery patients. And that showed that treatment of obesity is not only about substantial weight loss, but it's in particular also about reduction of mortality and all the obesity-related complications. So the biggest breakthrough in the past decade actually is incretin-based therapy. And we saw it also on the voting, that GLP-1 is one of the major things. And this is the Gila monster, and it has everything to do with these breakthroughs. Because GLP-1 and GIP were already discovered in the 80s. But this monster has saliva, and that's containing exidin-4. And that's one of the first long-term GLP-1 receptor agonists, and which is more likely, more like the modern GLP-1 receptor agonists. And that actually led to the breakthrough that in 2015, there was EMA approval of the high dose of GLP-1 liraglutide, and in the same year, also the naltrexone bupropion, which is oral medication. That's the other medication which typically acts through the reward system. Then in 2022, we had the long-acting semaglutide in high dose, also for obesity, and in 24, the GLP-1-GIP combination tirzepatide. These were major breakthroughs, of course. But now we see also that more recently multi-receptor modulators are emerging. So many dual receptor agonists, but also triple agonists with also a combination with glucagon. And this means that weight loss is approaching now 25 to 30% in the latest trials here. But beyond triple agonism, also very lately, quintuple agonism, so 5 agonists are in the pipeline right now, and more than 150 drugs are in the pipeline right now. Now, very lately also, a first oral non-peptide GLP-1 receptor agonist was FDA approved. And recent studies showed the GLP-1-based therapy, they can reduce major cardiovascular events, but also showed beneficial effects on a wide range of diseases. So, of course, type 2 diabetes, but also kidney disease, fatty liver disease, PCOS, osteoarthritis, OSA, but also effects on the brain, beneficial for depression, and very lately also shown to be beneficial for the combination obesity and addiction. So there's an overview coming up very soon. So in just 20 years, we've moved from stigma and limited options to mechanism-based, highly effective treatments of obesity with novel and promising endocrine therapies. Thank you very much.
Fantastic. Great. So now we heard a lot about the breakthroughs in the last 20 years, and it is super impressive. And now we would like to hear from you if this is a good reflection in these 4 areas, if there are other things that were left out, or any questions you have to the panel. And I'd first like to give our 2 past presidents the opportunity to discuss, and start with you, AJ, to comment on what did you think about the breakthroughs, and also outside these areas, what is a super major breakthrough for you because you couldn't participate in the one-word exercise?
Well, I consider myself as an early career dinosaur. And all of these beautiful developments were possible because of one thing, basic science. And in the 60s and 70s, it started off with the possibility to measure hormone concentrations in the nanomolar range, followed in the mid-80s by the PCR, 2 years later the RT-PCR, the first transgenic animals where you could add just one gene and never knew where it would show up in DNA. The first knockout animals, this was instrumental. So I would urge basic science, keep working, keep showing up at our congresses, because without you, endocrinology would be lost.
Yeah, I think that's a very important word for discovery science. And I always say, if we wouldn't have research, we would still put leeches on each other. And it would not be very comfortable as patients. Yeah, and obviously these monogenic discoveries were then flanked by multi-omics and other things. But over to you, Jerome, what are your thoughts?
Well, first, I would like really to congratulate our 4 speakers because they've summarized so many progress, 20 years of progress in such a nice way that's very informative. I agree with AJ that basic science is key, but basic science rely and is dependent somehow on the tool. And the progress comes from the methodological progress. And this is sure that omics at large had been one of the major tools that have been developed these last 20 years. So it changed the way we were thinking and doing science, coming initially to study a single hormone on a single receptor, a single cell, a single organ, to multi-systemic approach and thinking about network and signature. And so this led to the concept that there are interactions between organs, and even though we heard several examples of that, we don't always realize that this is because the tool available for science have changed the way we are thinking. And I think that endocrinology was very well prepared for this progress that apply, of course, to many different domains, because hormones goes everywhere, act on several cells. So this multi-systemic dimension, let's multi-target, is clearly in the thinking of endocrinology. And I think that's probably one of the specialties that benefit the most of that. And then all the therapeutic progress that we heard somehow benefit from this approach over the year.
Absolutely. I think it's one of the major things that endocrinology is a system science and doesn't look only through the microscope at one organ, but at the whole human, at the whole system. And obviously that also leads to the importance that Guillaume also mentioned of networking, of many scientists and clinicians coming together, phenotyping large groups of patients very concisely, and having the biomaterial to make the discoveries that transform the space. And obviously, Jerome and Guillaume, like me, are from the European Network for the Study of Adrenal Tumors, where over like 20 years, we systematically brought a biobank and a registry into place that then facilitated unbelievable numbers of discoveries. Yeah. Excellent. Somebody coming to the microphone. No, no, no. Any comments from the floor? Is there a big discovery that you want to highlight? Yeah, we put the lights on, no beach balls now. And you can make comments if you say, hey, you didn't talk about my field, but in my field, I think the transformative discovery is such and such. Don't be shy, come to the microphones. But otherwise, I talk. So perhaps, Guillaume, you can talk on multi-omics and networking also in more detail, if you like.
Yeah, I think it's the same, actually, in terms of a conceptual approach. A network of molecules or of humans is a network, and I think that when you integrate the multiple instances, you get a higher view on things, and this applies also to humans.
Absolutely, and I think that was paralleled, and you are obviously one of the leading experts with computational science developments and the application of machine learning and other things to biological data, and finding things in an unbiased fashion, I think, is also very important, because when I started in medicine, it was a hypothesis based on something, and then you tested the hypothesis. That is still nowadays a very important mechanism, but increasingly unbiased approaches have facilitated reverse translation and new discoveries. So I think the combination of unbiased approaches and hypothesis-driven research is extremely important. Nobody at the microphones yet? Okay. Great. One volunteer, Cesar.
So, great panel. Cesar Bogujes from Brazil. I would like to see the opinion of this beautiful panel about how these past breakthroughs can be incorporated and include people in the future. So we see now, in terms of resource, that we have limited resource for the health services around the world, and how to include more people to have access for the diagnostics and therapeutics that we discover. Because at least so far, I think this is it's good, but it's just for really few people that we can really have these treatments available.
Yes, so like how can we get equity and global access to new developments? This is a super important question. You know, like, are there some lucky countries? Are there some unlucky countries? So anybody commenting on this? Guillaume and Elena?
Yeah, I think this Malthusian view is interesting, and probably we have opportunities also to remove some useless things that will spare some bandwidth, I mean, on what we can afford. So probably things will recenter on more essential things at the same time. This could be a view. Another view is that when you move at scale, prices drop and processes improve. So I think that what comes out from research that we mainly presented is going to become standard products at low price. I would guess in a more positive insight.
Excellent. Sebastian.
So thank you very much for the beautiful overviews. I was wondering, this is for the younger elderly. So looking back last 20 years and which dogmas did disappear, if you look now 20 years ahead, if we would have our 40th anniversary, what do you think will be gone from what we use now as a dogma?
Okay, we are not answering this because the second half is basically the future. Okay. And then we will look 20 years forward, which will be shortly coming. Yeah, and Miriam will take over in moderating this. But that's exactly the thought we had. Juan.
Hi. So thank you for this amazing overview of such a different focus areas. I was wondering if you could comment on the role and the development of patient advocacy and what part they played on some of these discoveries.
Yeah, I think that's very important. Elena, do you want to speak to this, what the role of patient advocacy was in achieving all these breakthroughs, for example, in rare diseases?
Yeah. Yes, thank you for this question because it's very important. And as I said also in my presentation, one of the most important breakthroughs during the last decades is precisely the increased patient empowerment and involvement in many activities, also influencing research priorities. So I think that we should foster further these aspects because in order to address equality also, just to also remember the previous question, it's very important to know the unmet needs and patients are an important, at the center, we could say, of the entire process. And so this means also that we should further develop registries and also accessible to the patients themselves. And also to develop something interactive, such as apps, something like that, that could even, further their involvement.
Yes, and it is very important that the patients collaborate, like it's done in the UK with the James Lind Alliances, that they help to set the priorities for future research. Because we need to know what is there to an end. And I personally also challenge transdisciplinary science. And transdisciplinary science means that from the outset, from our research, we consult the public, patients, entrepreneurs, industry, and have a very good understanding what solutions are needed. Yeah, so this is sometimes otherwise a hindrance for engineers who like to build machines, but then nobody might need that solution. So it's important also, for example, with biomedical scientists to talk with engineers and computer scientists and to communicate with them what kind of solutions are needed. For all of us to be curious and speaking different scientific languages. Last question, last comment from John Voss before we go to the second half.
Thank you, Wiebke. I just want to say that I think this Congress and this particular session demonstrates very nicely the hegemony of European endocrinology over other parts of the world. And I think that's something which you should all be congratulated on. We've had some fantastic talks. In the next half, I think we should think about the political utilization of some of these advances. And in particular, I don't know whether in the Netherlands, but certainly in the UK, obesity should be recognized as a chronic relapsing disease, and it's not in the UK. And I think that that would in particular improve funding for obesity treatments that there are. And I think that's something the political use of the force of this society should be put to in the future.
Absolutely. Many thanks for all these comments. We will comment on obesity also in the second half, but just to let you know that we just had the summit of the presidents preceding the European conference with representatives from the European Commissions and from the Biomed Alliance to make sure that we even more effectively lobby our views for the better of all patients and healthcare and research. Okay, final short question or comment.
Yes, I'm a very old endocrinologist, perhaps since 60 years, because I'm near 19 years old.
Wow.
And I have seen
Thanks
many
for being here. Endocrinology keeps you young.
I have seen many progresses in my life, surprising progresses. And now I didn't hear much in this Congress about artificial intelligence. What will bring artificial endocrinology?
Yes, this is super important, and artificial intelligence will play a big role of what you hear about in the future part. Yeah, we are always forward-looking, and we talk to the importance of computational machine learning and artificial intelligence, and you will hear about it in the second part. So that's a cue now for the second video to be launched. What do we think could be something in the future, which will be the basis of the second discussion, which will be moderated by Miriam.
Friends and colleagues, we now welcome to the stage diseases, cancer in endocrinology, environmental endocrinology and endocrine-disrupting chemicals, and obesity.
So this is absolutely great what we have seen, what happened in the past 20 years, but now let's have a look into the future. What will be the future developments? What will we say at our 40th or 50th anniversary of the society? What will be the major breakthroughs then? And as for the past breakthroughs, we will again have short presentations, perspectives on the similar topics than we heard before. And these presentations will be given, or at least have been prepared jointly between one of our ECE members, so the young endocrinologists, and one of the established researchers that you have heard before. And this per se reflects an important message, and that is that the future actually grows out of its past, and it's shaped through a dialogue between the generations. So we will start again first with a word cloud. So you are invited again to scan the QR code. And the question here is, what do you think will be the greatest endocrine breakthrough in the next 20 years? So do you scan the code?
In one word again.
Yeah, just one word. Okay. 30 seconds left. Last 10 seconds. Okay, this is interesting. Omics, biosensors, fertility, prevention, expensive. Obesity, longevity, important. Cures, AI, we discussed it just before with 3 marks. Genetics, smart hormones, gene therapy. So we have a real diverse word cloud. And let's hear now what our young endocrinologists show us. I have to think, yeah. So we will start again with the rare endocrine disease, which will be given by Barbara Altieri from Italy. And then we pass on to cancer and endocrinology by Juan Jimenez Vacas from UK. Then environmental EDCs is Kristina Zaravinovska from Serbia. And lastly, obesity is Julia Beck from Switzerland. And as mentioned, you see this was jointly prepared with the speakers you just heard.
So thank you, Miriam, for the introduction. It's really an honor for me to represent the future of the rare disease. So what we expected for the future, one of the most important shifts is toward an early and more precise diagnosis. We are moving from a clinical phenotype-based approach to a molecular understanding of the disease. So next generation sequencing, including whole exome and genome sequencing, integrated by multi-omics, including transcriptomics and epigenomics, will improve in the future and will become the center for our diagnosis. And these will be assisted by AI to better recognize the disease and by incrementing hormone patterns, imaging, and genomic data all together. But beyond genetic data, we also have new techniques, including organoids and lab-growing endocrine tissue. This will allow to create a patient-specific models to study the disease mechanism, but also to test therapies in a patient-specific way. Moreover, also the artificial intelligence enhanced imaging will improve the detection of the lesion to characterize that, and in particularly in endocrine cancer. And these two will work together with the new radiotracer in the functional imaging that will allow us to better characterize specific disease and also to lead to targeted approaches. But another important step is to go from the control of the symptoms to disease modification. And this is important because the treatment also starts to change, and particularly we start to a specific individualized hormone-replaced treatment, starting from the genotype to phenotype correlation and clinical characteristic of the patients. And this is going together with stem cell-based technologies when we aim to replace the endogenous hormone secretion and in order to restore the normal production of the hormones. Moreover, we have gene therapies together with RNA-based therapies and gene editing that will allow to target the therapy, the specific genes that are involved in the disease. And this is going together with the targeted therapies, which allow to us to treat the disease without minimizing the adverse events. But also, at the center of the model on the treatment of it still remain the patient. But the patient and the treatment model will be help with the new models, starting with hormone replaced adaptive delivery system with the wearable device that will help us to monitoring the and interface a continuous monitoring with the physiology over time of our glucose, our hormones replaced treatment, for example. And also the teleendocrinology, which will allow the patient to reach expert despite geographic distance. And again here, we will have also the AI support in the clinical decision tool to predict models to improve the treatment, the strategy treatment of the patients. But also what it has to change in the future will have also, that we also expect a changing in the system levels. Multidisciplinary teams and center of excellence are important now and will be important also in the future, as well as also the increasing of rare disease registry that will allow to understand the long-term outcomes of the disease. And also we think about also to have a more expansion of the rare disease networkings. We also already saw before about ERN, but also patient advocacy groups. And this will improve to have high access to high quality data, but also improve what the patient needs. Moreover, we can use, thanks to these previous tools, we can use also real-world evidence to make a clinical decision and improve clinical trial, which are also a problem in the rare disease. And finally, we have to improve education and training program. And now for the conclusion, I leave the word to Elena.
So, thank you, Barbara. So we can say that, in summary, the future of rare endocrine disease is defined by four directions: early diagnosis, personalized treatment, better quality of life, and global collaborations. So in order to reach the goal of shorten the delay in diagnosis, we could use advanced tools and biomarkers which enable precisely early detection, and for personalized treatment, we can use techniques of gene editing that improve efficacy and reduce side effects. To improve quality of life, of course, we had to, put together all these tools, and as we have said before, increase the involvement of patients, and always include PROMs in our evaluation and in research. And of course, we have to foster global collaboration, including sharing data, knowledge, and expertise, as we discussed before. So it's science without borders, we could say, to accelerate the progress for everybody. Thank you.
Thank you very much, Barbara and Elena, for giving us this outlook in rare endocrine diseases. And we move to the next couple of speakers, and this is now Juan Jimenez Vacas from UK and Guillaume Assy about cancer and endocrinology.
So hello everyone, it is my pleasure and honor to be here, especially next to Guillaume giving this talk. So this is the way, or I envision that in the upcoming years, the clinical practice and the research in endocrinology and cancer is going to be massively influenced by this holistic view of cancer, a multi-layer system, and there are still some challenges to tackle in this regard. When it comes to the tumor cells, for example, in endocrine-related cancers, how to tackle the lineage plasticity in response to tumor therapeutic pressure. Then we have the role of the tumor microenvironment, not just with the immune cells, but also the vascular signals coming from the endothelial cells and the adipokines coming from the adipocytes. The role of the host organism with the increasing evidence of the microbiome in this regard, and the environmental signals, not just with physical activity and diet, as it was discussed, but the endocrine disruptors that nowadays we can find pretty much anywhere, and the important role of the stressors that we have to deal with in our daily life. And then these are the emerging cancer therapeutics that I envision for the future. Some of them are, as you could see, influencing more than one compartment. I think we should pay special attention to the influence of the next generation therapies for endocrine disorders and the impact that they will have in long-term cancer, indirectly and directly. And we should model all of this in the lab. I think we're moving from cell lines or even 3D cultures to living tumor ecosystems to mimic that the tumor cells are not alone, and the endocrine system obviously is part of the disease.
So let's zoom out a bit. We cannot forget to talk about AI. How is AI going to impact the field? I think it will completely change, of course, patients' care and research. One type of model is what I would call small models, which are already existing and developing. And of course, we want for cancer better diagnosis, treatment, recovery, understanding, and prevention. And these small models are now rising all over this deep structure of patients' management and research. And it's accelerating, improving efficiency. But the very structure right now is not modified. So novelty from there, the ultimate models. These models are able to encode the real to levels that human cannot catch. And just imagine operating such ultimate models to patients' care and research. We would end up with a system where we are not able to understand nor to control. So one, we will talk about that, but that's a problem potentially for you. Another important point is the experimental science paradigm. We have observations, we make hypotheses, then we test them. And in research, especially in computing science, recursion is very important. And research is recurrent because the testing results come back to a new cycle, combined to observations, and this leads to models. And the higher the number of cycles, the better the model. And right now, of course, one cycle in human life is 1 to 4 years in science. But with ultimate models, it drops to fractions of seconds. And what is happening when you accelerate this cycle to this speed? You can then not discriminate the input from the output, meaning the pre-hoc merge with the post-hoc. Consequences and causes just merge because it goes too fast. The consequence of one cycle becomes the cause of the following one. Where the value concentrates then is in the ultimate model. And of course, the control on it, the understanding on it, I think is a true question. So, one, in 20 years, I may be retired, but I fear for your future, you will be replaced.
So I strongly disagree with that. And I actually believe that not only me, but we are way better than AI. There are many reasons to believe in this, and obviously I don't have time to go through everything in detail. I'm more than happy to discuss this later. But I will emphasize the causality over association that is coming from the vast majority of these models and the need for human evaluation, especially when it comes to ethical and complex decision making. So I will kindly ask, please stop telling us that AI will replace us. And this is what AI can do quite good. Actually, I fed it with all the things that I've been talking about and Guillaume here during this talk. And it came up with this nice overview with plenty of inaccuracies, proving again that we need to supervise and oversee what AI does. But I think the key points here and words are for the future as a basic scientist too, so this is my internal bias. I think the future of endocrinology and cancer it's related to precision medicine, it's related to collaboration, multidisciplinarity, and more importantly, globalization.
So I will end up wishing this bright human network future in the United States of Europe. Thank you, Juan.
Thank you, Juan and Guillaume, for this almost philosophical outlook. So we go on with environmental EDCs, and this is given by Christina Zaravinowska together with Paulina.
So hi again. I finished off my previous presentation by saying that we have plenty of evidence over the past 20 years on the adverse effects of the EDCs, and it would be time to act. So of course, regulation must follow the science, otherwise the research doesn't translate into public health benefits. And chemical legislation updates have been promised to us repeatedly, and the dates are keeping postponing into the future. So an immediate future action would be that we actually implement all the promised changes in the European chemical legislation and get a safer environment. But while we wait for that, maybe some other things will also happen.
Thank you, Paulina. As Paulina showed us during the past perspectives, the past 20 years of breakthroughs gave us foundation, but also brought us here to this very moment. And as the next generation of endocrinologists and endocrine scientists, I think that we inherit not only the knowledge, but also the responsibility to act on it. And during the next few minutes, I would like to take you through 3 frontiers that we believe will shape the future of environmental endocrinology and endocrine-disrupting chemicals. And these are biomonitoring, wearable technology, and pharmaceutical repurposing. These are 3 horizons, each grounded in what the science tells us is possible. One of our first frontiers is biomonitoring, and we believe that a foundation for future action on EDCs should be to know who is exposed to what and at what level. And this is why we need coordinated biomonitoring at national, continental, and global level with validated biomarkers that can be used in both clinical and public health settings. The EU framework is already in motion, and by 2029, it is expected to have common data on chemicals. The only missing piece of the puzzle is the clinical one. What we need is validated EDC-specific biomarker panels for clinical use, which are still to be developed. And we are very optimistic and forward-looking that this may be, may happen in the 2030s. Considering that the biomonitoring is giving us the environmental picture, then the wearable technology could give us the individual one. And we envision a monitoring that is operating on 2 levels. First, the environmental tracking of volatile endocrine-disrupting chemicals in ambiental air, and the proof of concept already exists there. And this would be combined together with internal bioburden sensing through skin biofluids, and this is where the actual frontier lies. And we believe that this gap could be bridged by multi-omics, and this is through omics discovery, biomarker validation, and sensor integration. The ultimate goal would be a complete exposure to effect picture in real time with individual EDC exposure, which would be available to both the patient but also the physicians. And we envision that this could be also achieved in the 2030s. And our third frontier might surprise you a bit because we are not looking for new molecules. Our pharmacopoeia has drugs that have already shown promise to reduce the EDC bioburden. For example, bile acid sequestrants are shown to accelerate PFAS elimination in highly exposed populations, whereas dietary interventions reduce non-persistent EDC exposure. So the question no longer is whether interventions are possible. The question is where, when, and are we ready to act? And the next step would be to prove the clinical benefit at scale. So the past 20 years brought us here today, and the next 20 years, we believe it will be defined by what we decide to do with it, as researchers, as clinicians, and last but not least, as advocates. Thank you.
Thank you, Christina and Paulina, for giving us a perspective on this topic. And now we move to obesity. And this is Julia Beck from Switzerland, together with Lisbeth, whom we heard before.
Yeah, thank you very much, Miriam. It's a great pleasure and honor for us to present you the future of obesity. And out of all fields of endocrinology, probably obesity will be the most dynamic field for us as endocrinologists. In the last 20 years, a wave of new medication has emerged. However, this is only the starting point. Nowadays, treatment is mainly GLP-1 based, but in the future, treatment will emerge to multi-receptor modulators, small molecules for oral administration, immunomodulator therapies, and also microbiome engineering. Right now, we are almost able to achieve up to 30% weight loss, but just imagine what massive potential the future holds. We might be able to achieve way more than 30%, maybe 40 or even 50% of weight loss might be possible. We are truly moving towards pharmacotherapies that enable us as endocrinologists to mimic bariatric surgery effects. And it will be much more mix and match of combinations, and our treatment options will grow faster and faster. Next to also food intake, we think that a focus on energy expenditure increase will arise. We might be able to reprogram white adipose tissue into brown metabolic active tissue. And second, we might be able to increase skeletal muscle growth to further support the preservation and maybe even increase of skeletal muscle growth during obesity care. So we are moving towards a true metabolic reset for our patients. And the third part will also be AI and precision medicine. We know that treatment response in obesity care is much heterogeneous, but with the help of AI, genomics, wearables, and real-time data, we might be able to predict treatment response and to really support our patients along their journey.
Yes, and in support, in addition to the wearables and the biomarkers, we also need a lot of individual characteristics about person's lifestyle, psychosocial factors, medication use, and other medical conditions. And actually, now at this Congress, also in the Sunday session, the tool checkcausesobesity.com has been launched, which is a validated science-based screening and monitoring tool. Also, monogenic obesity can be detected, for example, but you can also monitor. So this can be a beginning of precision medicine, individualized therapy. Next, we expect that also gene therapy for monogenic obesity will be ready to go. We have CRISPR techniques just like for other diseases. And actually, sometimes you see that there are other factors for people. So you see here, looking at this wallet on the left, some people have, for example, financial debt. They have difficulties there with, and we need also to give, you see it on the right side, he has money now, to have to assist from the psychosocial level. So we need to change systems also to support the healthy lifestyle. And on the left, you see a supermarket full of ultra-processed food, which is reality right now. 80% in the supermarkets right now is unhealthy. But now, interestingly, also based on this new endocrine therapies, we know now there is a shift going on right now, and it can be in the future extended. Now, in the United States, 1 in 8 is using obesity medication, and we see a change in consumer behavior. Recently, there was a press release that American supermarkets, they're heavily concerned because their sales on unhealthy product is drastically decreasing. But actually that's good news. So maybe in the future we have more healthy supermarket enabling us to adhere to a healthy lifestyle. This is more about the prevention part. But to finish, I like to finish with a metaphor. And the metaphor is, you see burning house, and that's obesity. And below you see a lot of doctors, like firefighters, they're trying to extinguish all the fires, and we call them all the obesity-related comorbidities. They're working very hard on that. And at the same time, on the right, you see European governments. They're actually pouring oil on the fire. And that's actually the case. I showed you that almost 80% in the supermarket is unhealthy food right now. And there are so many other endocrine-disrupting chemicals, and we lack the legislation to really handle this. So what should we do for the future? But first of all, we as endocrinologists should raise our voices to the European government to pour water rather than oil. And that means ask for a ban on marketing and unhealthy food. We need sugar taxes in every country and make lower prices for healthy food. So measures, that's for prevention. But at the same time, there are already people who have obesity, recognized as a disease. And what we need for that, we need to follow the guidelines. That means check the causes first, then adhere also, provide lifestyle interventions, provide medication where needed and Berg surgery when needed. And if we do both, if we at one hand do prevention and we do the treatments, then we can really tackle the obesity treatment in the future.
And we are both convinced that the future of obesity is not just about weight loss, but it's about controlling biology, behavior, and the whole system around it to really be able to increase the quality of life of our patients.
Thank you.
Thank you, Julia and Lisbeth, for the last topic. And now we open the floor again for the discussion. So if you want to come to the microphone and ask a question or comment, also the young ones, please feel free. But first, we start again with our two dinosaurs. That's what you named yourself, Jane? So how would you comment? Whoever wants to start?
The real dinosaurs.
This is impressive. The outlook is unbelievable. And if you look down to the very basics of modern medicine, it's all about how to study, control, and modify the transportation of information. From the nucleus to the cell organelles, from the cell to the other cells, from the cells to the tissue, from tissue for organ to organ. And we share that interest with some other specialties. And I think it would be a great idea if some of our young basic scientists and translational scientists also show up in other congresses than the European endocrinology. Go to a congress on immunology, neuroscience, and oncology, because you will meet there your pals who do the same trick at the other side of the wall. And I think we don't need walls, we have to break them down.
Yeah, you point to a very important point. Jerome, how do you comment?
There is not a single talk today without reference to AI. And I appreciate very much the fight between Guillaume and Joan on that topic. And I think we all have great expectation with AI because, going back to my initial comment, we have now so many information that our brain is not able to synthesize all this information, or at least to synthesize it fast enough. And AI, of course, is clearly the tool for that. But at least for my generation, we don't know anything about AI. And I will urge the young endocrinologists to be involved actively with AI and to learn how it's working. Of course, there are need for mathematicians and specialists, so that's not what we are going to do as endocrinologists, but you need to control the tool. Otherwise, what is going to happen? The tool will be completely dehumanized, and then the patient will not need you anymore. And I'm not sure that patient use of AI will be beneficial to them on the long term. So I think this is, I agree with both of you. I might take over, but you need to do everything to control it. And of course, the European space for that is probably much more prepared than outside Europe. So that should be your goal.
As Juan mentioned, you should be better than AI. So now there is a question from the audience.
If I may.
Yes, thank you very much for this nice, festival of the 20th anniversary of our society. I am also a sort of dinosaur. So, or almost, I am applying to become a dinosaur, if you can take me in your club. And I think my considerations are the following. First of what I bring home from here is that first, it's much easier to talk about what happened in the last 20 years than to envision the future. And the vision is the problem. So all what you exposed here, I'm not talking to the young people, but to everyone, is something that somehow is easy to foresee. We also know that in science, many breakthroughs come through serendipitous findings. And we should not underestimate the role of serendipitous findings in our future. Then it's nice to talk about rare diseases, but clinical endocrinology is a discipline dealing with diseases interesting 40–50% of the populations, because you know that they are chronic diseases and so on and so forth. And in this epidemiology, there are two main factors that we see in our ambulance every day. First is obesity, and with obesity we are on the right track, I would say. And the second we see is osteoporosis. And osteoporosis is not relevant per se, but is extremely relevant because it's a disease of the postmenopausal woman. And I haven't heard any word here about reproduction, endocrinology of reproduction, and this is not a surprise, because you are right, there were no breakthrough in endocrinology of reproduction in the last 20 years. And one of the reasons is that endocrinology has abdicated reproductive endocrinology to the hands of gynecologists and urologists. So my appeal here is endocrinology should take possession again of this part, of very relevant part, because reproduction is the basis of where we are here. And if you consider that the demographic evolution of our world is dramatic, in Europe is already dramatic, it's not only about decreasing of the births, it's also about diseases of the old people. And postmenopausal women will be very soon a very important proportion of the world population. And I remind you that they are suffering of hypergonadotropic hypogonadism, which is not only a matter of sex, it's a matter of important metabolic consequences that we have never been regarding in the proper way. So if we leave the situation like this, most probably in the next, not 20, but 1 century or so, we will be on the right way to, let's say, solve the problem of endocrine disruptors by decreasing dramatically the number of the world population. So if we decrease of the world population of 4 billion, probably we have also resolved the problem of endocrine disruptors.
Thank you very much. So we have a lot of questions. I think first, Alberto, you were the next.
Thank you. First of all, I want to congratulate the panel for the excellent presentations and the foresight. I also would like to challenge you. And let's start with precision medicine. I still saw a gap, in my opinion. We as endocrinologists were still not able to provide optimal hormone replacement therapy. So for instance, how do the panels see, so the 2017 Nobel Prize was awarded for circadian and ultradian rhythm biology, which to me exemplifies the critical role of endocrinology linkage to the molecular clocks. So would any of you would like to comment about the gap that I identify in optimizing personalized therapy or hormone replacement therapy using AI and all the other tools that we have here?
So clearly a question for one of the young ones. Who wants to comment?
Okay, this is really important question, so thanks for asking that. The hormone replacement therapy, unfortunately, is not optimal, and every one of us know it. The use of the AI will be like together with tools that can improve, for example, to see, for example, the circadian rhythm of some hormones. I think about the glucocorticoid replacement therapy for the adrenal insufficiency, but also we know that there are some already for like better tools also for the control of type 1 diabetes, but also will still not optimal. And in the future, together with these tools, probably we have also to, there will be also stem cell based treatment, because this will be really the key, because if we will be able to switch stem cells and into the, let's say, to the hormone, the cells that don't work anymore, let's say, and produce the hormone in the physiological way, that will be the key.
Yes, but I think that you all agree that optimizing hormone replacement therapy is still a key feature and priority for the next 20 years.
We don't have we don't have yet. Yeah.
Thank you.
Thank you, Alberto. So we have another question on the left side.
Yeah, hello, Trine Finnes, Norway. As an endocrinologist, I often have the feeling we are the only one caring for those with the rare endocrine diseases, of course. And there's a lot of stuff to do there. And on the other hand, we are caring about those very common diseases, nearly pandemic, as obesity. So my question to the young endocrinologist is, how would you, in the future, with probably reduced resources for health, how would you prioritize developing precision medicine for our rare diseases and take care of our very common diseases, please?
Yeah, that's a very important question. So, who of the young ones? You again?
I answer because, like, we are talking about rare disease. We know that rare diseases are rare, but we have to also increase the knowledge about this disease, because they are rare, but they exist. And although in our daily clinical practice, we see more patients with thyroid problem, or we said osteoporosis or type 2 diabetes, but patients with rare disease exist. So we have to also improve the awareness of these patients, and that's why it's important then to, let's say, to have excellence center to the treatment for those patients, because maybe if we will have in our clinical practice a patient with this rare disease, we can help them to reach the excellence center that treat these patients. And this should be also then the priority where for example, for the funding for the future. So, for example, recognize excellence center to improve that, and all the other more, let's say, frequent disease probably can be treated more locally. It's not, it's a tough question, yes, but for sure both of them are important.
Maybe I can add, Barbara, as you touched on obesity topic, I think it's still important that we as endocrinologists have the expertise and the knowledge of also monogenic obesity, and to keep an open mind, but also to teach family doctors, general practitioners in this area, right? Because you also mentioned the problem of money in the end, right?
Yeah, it will certainly be very important to keep the balance between both the very common diseases and the rare diseases. John.
So thank you. It's been very interesting, and I should congratulate you. It's a comment or perhaps a challenge to the question around AI. And I am on the Guillaume Assay side of AI, in the sense that there is a danger. And so the comment and the challenge to the next generation is to absolutely ensure that when the implementation is done, that you collaborate with the social scientists, with the anthropologists, for the people who really understand the societal implications, because the back propagation, which is the way the AI models are trained, depends entirely upon the social context in which they're being utilized. So you will get different answers in different social constructs in different countries. So there won't be one size that fits all across the whole of Europe.
No, I fully agree with your point, and actually I just want to emphasize something that maybe I didn't have time to go through in detail in my slides, but I'm not saying that obviously, AI, I'm saying AI won't replace us, But those researchers, again, this is my bias as a basic scientist, and even the clinical scientist, the ones using AI will replace those who are not using it. And obviously we need to take into account all of the legal, background legal, probably you can even comment more than me based on the No Compass article that you wrote. But it's something obviously to take into account. You want to comment? It's okay.
Okay, I'm sorry, we have just one quick question and that's the last one. Thank you.
Thank you very much. It was fascinating. As an endocrinologist of 30 years, I'm always starting my introduction lecture to the students saying that we only see the tip of the iceberg in endocrinology right now. And what's missing mostly is the tissue endocrinology and receptor mechanisms where we haven't been entangled yet. So I would hope in 20 years we'll still be around to see more discovery on the receptor specific mechanisms that hormones and hormone disruptors would affect. Thank you very much.
If I may answer that one very quickly. I love the question. Thank you for bringing that up, because sometimes, and this is related also to the AI and the omics, we keep focusing on this kind of really bird's eye view of everything, trying to integrate so many data. And maybe I don't have such a young, mindset as the supposed to be dinosaurs here, but I still feel that we need to address those specific mechanisms, molecular biology, that we sometimes take for granted that we know, and we are so far away to know in the specifics. So I fully agree with you.
I think it's also important to think about tissue-specific mechanisms and also about tissue-specific delivery. That's obviously a big thing that we didn't mention so much, which might be really something for the future. But I would plead for the last word from the oldest endocrinologist, and then we close.
We may be very happy of the progress which has been realized and the progress we foresee in the future. But I will say something about my hope that the future endocrinologists remain good clinicians, able to listen to the patient and to examine them.
That's a very... A very good final conclusion, but let's come to an end now. I think we can conclude that the future of endocrinology is bright. It looks bright, and I already look forward to the 40th or 50th birthday where we all will be dinosaurs already. So it's good to see how much innovation lies ahead of us, and also that we learned that the dialogue between the generations remains very important. And I'm especially thrilled to see all you young endocrinologists and how much energy and vision and ideas you have. So thanks to all the speakers and the panelists and the dinosaurs, and thank you very much. I close this session.